insulator, what is conductor, and what is semiconductor. Okay. According to conductivity of solids are classified into three types. First one is insulator. Second one is conductor. Third one is semiconductor. What is meant by insulator? Insulator means, suppose any materials which do not conduct electricity, such type of materials are known as insulators. Okay? Insulator means material which do not conduct electricity. Okay? So according to the band theory, the solids has conduction band and valency band. Valency band is filled with electrons. That electrons are known as valency electrons. Okay? Valency band filled with electrons. That electrons are known as valency electrons. And the conduction band filled with electrons. That electrons are known as free electrons. Electrons present in the valency band are known as valency electrons. These electrons are known as valency electrons. Electrons present in the conduction band are known as free electrons. There is a gap between the conduction band and the valency band. This gap is known as energy gap. Gap between valency band and conduction band is known as energy gap, or also known as forbidden gap. Okay. So in the case of insulators, this gap is greater than 3 electron volts. Energy gap is greater than 3 electron volts in the case of insulators. Because of this large gap between the valency band and the conduction band, electrons cannot jump from the valency band to the conduction band. So no electrons present in the conduction band, only electrons present in the valency band. So there is no conduction in the case of insulators. Okay. In the case of insulators, resistivity is very large, conductivity is very low. Because of high resistivity, electrons cannot jump from the valency band to the conduction band. At 0 Kelvin temperature, valency band is completely filled with electrons, conduction band is completely empty. Okay? So at 0 Kelvin temperatures, no electrons in the conduction band, only electrons present in the valency band. Because of this reason, resistance of insulators are very high. When the resistance is very high, conductivity is very low. Okay? Resistivity is high, conductivity is low in the case of insulators. Next, coming to the point, conductors. What are the examples of insulators? Insulators examples are, you can say, wood, rock, and etc. Okay? Next one is conductors. Conductor means, according to the band theory, there is no gap between the valency band and the conduction band. Okay? But conduction band and valency band are overlapping with each other. There is no gap. There is no gap means like this. This is valency band and this is conduction band. So valency band is filled with electrons. That electrons are known as valency electrons. Conduction band filled with electrons. That electrons are known as free electrons. So because of no gap between the conduction band and valency band, electrons can easily move from valency band to the conduction band. Then some electrons are present in the conduction band. Because of electrons in the conduction band, the conductivity of conductors are very high. When the conductivity is high, automatically resistance is very low. So resistivity is low in the case of conductors. Conductivity is very high in the case of conductors. Gap between the valency zero. We can say there is no gap between the valency band and the conduction band. Examples for conductors. Examples for conductors are all metals are examples for conductors. Okay. Next one is semiconductors. Semiconductors are special materials. Compared to the insulators and conductors, semiconductors are special materials. Why semiconductors are special materials means, according to the general discussion, current causes due to the only motion of electrons. But in the case of semiconductors, current causes due to the motion of holes and due to the motion of electrons. Okay. Now we will discuss about that semiconductors. Semiconductors properties are always between the insulators and the conductors. Between the insulators and the conductors means, what are the properties of insulators? Insulators properties are, so the gap between the conduction band and valency band is greater than the 3 electron volts, and resistivity is very high, conductivity is very low. Okay na? Insulators which do not conduct any electricity. Conductors properties are what? Resistivity is very low and conductivity is very high. There is no gap between the valency band and the conduction band. Okay na? Now in the case of semiconductors, the gap between the conduction band and valency band is less than 3 electron volts. This is conduction band. This is valency band. Valency band is filled with electrons. The electrons are known as valency electrons. Conduction band filled with electrons. That electrons are known as free electrons. At 0 Kelvin temperature, there is no electrons in the conduction band. Only valency band is filled with electrons. Conduction band is completely empty at 0 Kelvin temperatures, right? So there is a gap between the conduction band and valency band. This gap is less than 3 electron volts. In the case of semiconductors, gap between conduction band and valency band is less than 3 electron volts. Means less than insulators and greater than conductors. Energy gap of semiconductors are less than insulators and greater than conductors. Because of this reason, we can say semiconductors properties are always between the insulators and the conductors, right? So, here energy gap is less than 3 electron volts at 0 Kelvin temperature. Valency band is completely filled, conduction band is completely empty. And resistivity is moderate and the conductivity is also moderate. Okay na? Conductivity and resistivity both are medium in the case of semiconductors. And one more special property of semiconductors are, at 0 Kelvin temperature, semiconductors are acts like insulators. When the temperature is greater than 0 Kelvin, semiconductors are acts like conductors. Okay? So, semiconductors properties are always between insulators and conductors. So, what are the examples for semiconductors? Examples for semiconductors are germanium and silicon. Germanium, silicon are the examples for semiconductors, right? Next, semiconductors. Now, how many types of semiconductors? Types of semiconductors. There are two types of semiconductors. First one is intrinsic semiconductors. Intrinsic semiconductors. Okay. Second one is extrinsic semiconductors. Extrinsic semiconductors. So intrinsic semiconductors. Intrinsic semiconductors means chemically pure semiconductors. Chemically pure semiconductors are known as intrinsic semiconductors. Chemically pure semiconductors means there are no impurities. Impurities are less than 0. Okay, less than 1. Intrinsic semiconductors means chemically pure semiconductors. Examples for intrinsic semiconductors are germanium and silicon. Okay na? semiconductors. So at 0 Kelvin temperature, valency band is completely filled with electrons. Conduction band is completely empty. In the case of intrinsic semiconductors, so valency band is completely filled with electrons. Conduction band is completely empty at 0 Kelvin temperature. There are no electrons in the conduction band. There are no electrons in the conduction band. There is no current. Okay, na? Because current causes due to the flow of electrons in the conduction band, flow of holes in the valency band. What is hole? What is hole means when the temperature is increases at 0 Kelvin temperature, intrinsic semiconductors are acts like a insulators. When the temperature is greater than 0 Kelvin, this is valency band and this is conduction band. Electrons absorb external energy. Then electrons jump from the lower energy state to the higher energy state. Electrons jump from the lower energy state to higher energy state. These electrons are known as free electrons. Okay, so that vacant place when the electron jumps from the valency band to the conduction band, where place is vacant, this place is known as hole. Okay, free electrons gives negative charge, hole gives constitute positive charge, right? So when electrons jump from the valency band to the conduction band, electrons are now in the conduction band. These electrons are called as free electrons. Why these electrons are called free electrons means electron can move freely in the conduction band. Electrons cannot move freely in the valency band. That is the difference between valency electrons and the free electrons. When a valency electrons means that electrons cannot move in the valency band. Free electrons means electrons can move in the conduction band, right? At the same time, so holes, when the electrons move from the valency band to the conduction band, here two electrons are created or generated. At the same time, two holes are generated in the valency band. So electrons can move in the conduction band, same like holes moves in the valency band. Due to the motion of electrons, these electrons causes current. Due to the motion of holes, current is known as hole current. Okay, na? So this current is known as electron current. This is represented by IE, and hole current is represented by IH. In the case of intrinsic semiconductors, total current is equals to the sum of the electron current into hole current. One more important point in the intrinsic semiconductor: number of electrons present in the conduction band are equal to number of holes present in the valency band. How many electrons are present in the conduction band? 2 electrons. So here any number of electrons are equal to 2. Number of holes are equal to 2. So it is intrinsic semiconductor. Ne is equals to NH. This is about intrinsic semiconductors. Intrinsic semiconductors means chemically pure semiconductors. Okay. Examples for intrinsic semiconductors are germanium and silicon. In the case of intrinsic semiconductors, at 0 Kelvin temperatures, intrinsic semiconductors are acts like insulators because only electrons are present in the valency band, no electrons in the conduction band. If no electrons in the conduction band, there is no current. There is no current means that intrinsic semiconductors are acts like insulators at 0 Kelvin temperatures, right? When the temperature is increases, electrons jump from the lower energy state means here valency band to the conduction band. Now electrons present in the conduction band, holes present in the valency band, then current starts flowing in the devices. So here important point in the intrinsic semiconductors are number of electrons in the conduction band are equal to number of holes in the valency band, and the total current of intrinsic semiconductors are sum of the electron current and hole current. What is hole current? Hole current means current causes due to the motion of holes in the valency band. What is electron current? Electron current means current causes due to the motion of electrons in the conduction band, right? This is about intrinsic semiconductors, right? Next, extrinsic semiconductors. Extrinsic semiconductors means impure semiconductors. Impure semiconductors means by adding impurities to the pure semiconductors, we get extrinsic semiconductors. Extrinsic semiconductors are also known as impure semiconductors or doped semiconductors. Why these are called as doped semiconductors means by doping with impurities we get the different type of semiconductors. So because of that reason these semiconductors are known as doped semiconductors or impure semiconductors. Why these are called as impure semiconductors means they are by adding impurities, by adding other atoms, other elements to the pure semiconductors, we get impure semiconductors, right? What is doping? Doping means adding of impurities. Adding of impurities to the elements are known as doping. Okay, now? Next, extrinsic semiconductors are two types, p-type and n-type semiconductors.